Good afternoon. My name is Aaron Armstrong. I'm here with my colleague Jeff Gentile, and we are with the Common Application. And today we're going to present on a project that we undertook to improve the backup and restore capability we have for the servers that we run in AWS.
Should be just a single click.
Yep. No. All right. So I'll start off with a little bit of background about us. The Common Application is a not-for-profit. We've been in business for a little more than 40 years, and we provide a platform for high school students to be able to submit their undergraduate college applications online. We are a membership association, and currently we have more than 500 colleges that are part of that membership, and those colleges allow students to apply to their institutions using the Common App system. So in terms of the scope of our user base, we have two primary user groups. The first being the students themselves, the applicants, and in our most recent season, we had more than 800,000 students who submitted a combined more than 3.5 million application forms. The second primary user group is made up principally of high school counselors and teachers who are submitting supporting academic data as well as recommendations on the students' behalves. And in our recent season there, we had a little over 1 million users who submitted a combined total of more than 14 million electronic data forms. So in terms of our use of AWS, we run our entire infrastructure on AWS. We don't have any on-premise assets, and we don't have any servers in any data center. We use most of the core infrastructure services that you're probably familiar with, EC2 for virtual machines, RDS for relational database, and Dynamo for NoSQL. But we also use some of the application services like Simple Workflow and Simple Queuing Service. In terms of our team size, we have 7 engineers who work within the DevOps team, and they work in a larger technology team that's made up of about 35 people. So we're actually just coming up on completing our second full year of running our production workload in AWS. And of course, in our early days, we were focused just on understanding the capabilities and getting those capabilities to work with our application system. One of the nice things that you discover when you're working with AWS is how quickly you can iterate with changes and ideas as they come to you. And so with some full operation under our belt during the course of the last 6 months, we've really turned our attention on where we can make improvements and revisit some of our previous decisions and approaches, looking for opportunities to have better processing efficiencies, taking advantage of automation in more ways, particularly using the AWS APIs, and reducing our overall cost footprint. So it's kind of been in the context of that mindset of continuous improvement that we had a specific project around taking a look at our server backup and restore capabilities. And so Jeff is going to talk you through the details of that project and the improvements we were able to make.
Thank you, Aaron. Everyone hear me okay? Perfect. So before I get started, how many in here already have a backup and restore process that you're using right now? Show of hands. Perfect. Of those folks that have their hands up, how many are still doing it manually and not automating any portion of that? Wow, nice. Nobody. That's good. Do you need me? Need me here anymore? Everyone? All right, good. So here's the agenda I have laid out for today. talking about our story, how we kind of went about things. So what was the problem that we faced? Well, it was mainly, we had backups, we had some restorability, but it wasn't a honed process, and really how we got to a more formal backup process and a more formal restorability process, along the way documenting the entire process. Next, I'm going to show you what our ecosystem and lifecycle looks like from instance to backup to restorability. Next, I'm going to talk a little bit about where we wanted to go as an organization and as a DevOps group, kind of big picture ideas as we kind of go through this entire backup and restorability process. What was our perfect world scenario? Once we had that kind of checklist of things that we wanted, how do we go about completing those tasks? Talk a little bit about that, what we looked at. This portion of the presentation where we talk about the solution, this is really the heart of the presentation where I really go through what exactly we're doing for backups and what we're doing for restorability. I have a lot of nice screenshots. It's not very technical in nature, but this really digs down into exactly what we're doing without showing you any code. So kind of reflecting back on the checklist that we had created from the step, a couple steps above, where we are today and what that looks like and how we accomplished our goals. To kind of close the session, how you could possibly leverage some of the things that we undertook and things that we implemented, and just some of the other benefits using the AWS APIs to help us since we operate multiple AWS accounts in multiple regions. And then I was talking with Leo, and apparently there hasn't been any time for questions at the end. So if you do have any questions or you want to see me about anything, Aaron and I will stay after if you have any questions. Okay, so the problem we face. So stepping back a little bit, within our fleet of instances, we really classify these as two different types. Long-lived or static servers versus the scalable servers, or auto-scale servers. The auto-scale servers are really the machines that host our application, the machines that once you launch them, we assign code to them, and they serve application traffic. Now, these instances do not have any data persistence, so we don't need to back those up. So we're really going to be talking about our static servers like NAT, VPN, FTP, LDAP, if anyone uses LDAP, things like that. And again, when you do backups, the reason you have backups is so you can restore in case something happens. And that's really what we focus on, really honing in our restorability. But as we got to our restore process, we really kind of figured that we needed to go back and look at our backup process as well. And the two things we looked at as kind of metrics for restorability, quickly returning to operation as fast as possible, and retrieval of lost data. Hopefully there aren't any. So what I'm going to be explaining today is the example is going to be our FTP site. The reason is because it hosts hundreds of gigs of data. It's used every day by our members, and there are hundreds of them. So many, many users use this every single day. And since the data that is on this FTP site is mission critical for our members, it's mission critical for us to make sure we don't lose any of their data. So here is what the ecosystem and life cycle really looks like for us. So starting at the very top, we have our FTP site running as normal. Down below, that Rundeck job, does anybody use Rundeck or have heard of Rundeck before? Show of hands. So one, just a few. Hey, my guy's back there. So Rundeck is an open source job scheduler. So what that really means is if I write some PowerShell or some Python scripting, I can create a Rundeck job, put that code into Rundeck, and then anybody logging into our Rundeck UI can run it right from that UI. No sharing of code between colleagues, not having to worry about libraries installed within Python or PowerShell. It's all run all on one platform, and that is Rundeck, and that's how we use it. So we have a Rundeck job that takes snapshots of our static servers. That Rundeck job points at a Python snapshot script, and that snapshot script gives us our snapshots, which live within our AWS console. So now, let's say, we're down at the very bottom, our FTP somehow crashes and nobody can get to it. We can't even RDP into it. What do? We've maybe have heard from Amazon that, yeah, that piece of hardware crashed. So we need to go ahead and restore that as soon as possible. So we use Rundeck again. Rundeck hosts our restorability script. So that Rundeck job points to that script, and then it gets relaunched as a brand new instance. I'm going to show you a lot of nice screenshots later on of the Rundeck UI and how that restore actually works and what the output of our restore script looks like. So don't worry about that. I'm going to be going through all of that in a minute. So we really brainstormed as a group and an organization on what we really wanted to achieve from this effort that Aaron was talking about, backups, restorability. And here's what we came up with. We wanted all of our static servers on an automated schedule. That way, one of the DevOps guys didn't always have to go in and manually click create snapshot or remember to do it, because we all forget things. So had to have them on an automated schedule, and that's what we use Rundeck for, because in Rundeck you can create them you can run them ad hocly, you can run them every week, every day, every hour, however you want to do it, much like a cron job if you're using cron jobs. So this is a cron job with a UI, pretty much. So rapid restore, so when a server is down, you want to restore that as soon as possible with as little inconvenience to your users as possible. A manual and scripted restore option. Basically, we wanted to do a manual at first, just in case anybody on our team was unfamiliar with how the script works. So we wanted to document that entire process, have that honed, and then go for the scripting. And the scripting is what I'm really going to be focusing on during this talk. We wanted to be able to add and remove servers over time. Within our organization, we may spin up instances, much like Rundeck. Rundeck is fairly new to us. We wanted as we consider a static server, so we want to get that backed up. So by our process, we can certainly do that very quickly. And then lastly, show of hands again. Manager, director, and above, can you raise your hand? Perfect. I have some good stuff in here for you too, because you guys don't necessarily know how to make the sausage, but you want to make sure the sausage is made. So we have some stuff in here to show you as well. So now that we had our list of things we wanted to accomplish, how do we accomplish them? Well, there's always buying a third-party piece of software. We looked at something like Schedly, which is just a normal software as a service provider. A nice thing about them is they were fairly cheap per operation, and we could quickly implement them. However, we chose a different path. We chose to do this all on our own for the reasons you see up on screen. So, our group was really gaining expertise in Python and Bodo. Many people in here use Python and Bodo together. Show of hands. Just a few? Okay. So Bodo is the SDK for Python to get to the AWS API. So that's just the flavor that we chose. Within our group, again, we have a lot of different systems that we manage. We didn't want to have to remember another URL, another username, and another password. We have plenty of those already. And again, this was something that we could definitely take on our own. If we did it our own, we could tailor it to our specific needs. So Schedly had a lot of different modules that we could have utilized, but we had a specific need in mind, and we could certainly do that ourselves. And being a not-for-profit, as Aaron said in the beginning, we are always trying to be as budget conscious as possible. So doing our own solution, there was no net new cost. So probably resonates in here as well. So this slide really acts as a high level for the slides I'm going to be showing coming up next. So as I mentioned before, our snapshot script is through Python, the Bodo SDK, and it's all instance and snapshot based. Why is this good? Well, this is great because our Python script can be written once, and we don't have to touch it to add and remove servers. That script looks at the instance tags to determine whether it should be backed up daily, weekly, monthly, or if it should be backed up at all. So I'm going to show you some nice screenshots there. Snapshot removal based on tags as well. Again, part of that EBS snapshot script, the last portion of that, it goes through a delete process. Again, all based on tagging. As your backups accumulate, you may not want a full year's worth of backups, and you don't want to remember to go back in and delete them because it's going to cost you money on the S3. A small amount of money, but again, you want to keep your AWS console as clean as possible and reduce your costs at the same time. And a push button restore process. This is really, again, the heart of this presentation, talking about restorability. I have a lot of good stuff on that coming up. So looking at our instance tags, this is just to give everybody context within the EC2 instances console within the AWS screen. Zooming into that, here are the tags that we have for our instances. Right here, this server type, this is the main driver for that script. That script, the first line it does is say, get me a list of all the instances that have that tag. Grabs them all and puts them in a list that Python can then use. From there, now that I have my list, I determine if I need to take a snapshot of it every single day, whether it's weekly, whether it's monthly. For weekly, we do every Sunday. For monthly, we do the last Sunday of every month. So we have instances ranging throughout. And retention days. How long do we want to keep that snapshot around for? Typically, our process is any daily we keep for 30 days, weekly we will do for 90, and monthly we may do a full year. A quick addendum to this screenshot. How many in here want to do backups hourly or every 2 or 3 or 4 hours? Anybody see a need for that? Perfect. So we just recently went through an update to this script to allow for that. What we did was we repurposed this tag right here, and we put in a comma-separated list of hours that we need to back it up. So for FTP, if we wanted to back it up 3 times a day, we could put in midnight, 6 a.m., 12 a.m. And when that script in Rundeck runs every single hour, it'll say, hey, when I parse out this comma-separated list, is this hour in there? If it is, take a snapshot. If not, tell me I don't need a snapshot until 2 hours from now. So that's one quick thing that we did that I'm not showing on screen. But again, if you want to do it hourly, you can go all the way down to that. So, snapshot tags. So once this script runs, our snapshots are created. One key thing to note, our FTP site has 3 volumes attached to it, so it creates 3 different volumes. A 80 gig system drive and 2 1 terabyte data drives. That's important for what I'm about to show you. Again, all based on tagging. So the name, we like to use a dot notation, so it's the name of the instance, snapshot, year, month, date. That device is very important for us, and it may be for you too if you're doing something similar. When you have multiple volumes on your instance and you restore or create from a snapshot, how are you going to know what volume to attach that new volume to? Well, with our scripting, we put the device. So just looking at this, I know that this is a data volume, not a system volume. System volume would be something like dev/SHA1 or whatever, SDA1, I believe it is. So looking at that tells me, and it tells the script as well, so whether we're doing a manual restore or a scripted restore, somebody or the script knows exactly where to remount this volume. Looking at the instance type right down below, this is nice because we can restore that instance to the exact same instance type that it came from. That way we're not over or under what we have. We certainly don't want to create a 2XL on a T2 micro. That would be bad. The next one, IOPS and volume type, kind of go hand in hand. Again, very similar to the instance type. We want to know what type of volume this came from. That way, again, this is a provisioned IOPS SSD drive with 1,000 provisions. We probably would not want to create a magnetic disk for this volume. So that tells us if we visually have to restore or the script exactly what to create. Going down the location, this just tells us where the instance and the volumes were. This managed by, again, much like that server type key and static value on the instance, this managed by is the driver for our delete process. So any snapshot that has that key value pair, create a list of them. Once we have a list of them, we look at that retain until. That retain until will tell us exactly when that's going to be deleted. Up top here in the name, you can see it was created on 6/6. Since it was daily, has a 30-day value for retain days, it creates 7/6. So there's your full 30 days. And then just source instance and the volume ID, we just put those in there just to have them. They're really not important for our scripting purposes, but since you can have 10 tags, we used all 10 tags. All right, so that took care of the backup and snapshot process. Moving forward, we're going to be looking at the restorability. Here is a screenshot of what Rundeck looks like. From there, we're really going to look at the main portion of the UI. Within Rundeck, you can have variables in your script which are inputs within Rundeck. So at the very top here, when we're doing our restore, we have a few of these inputs here. So this copying security groups, we have a true-false dropdown. So when we restore, we can either attach the correct security groups or we don't have to. A main reason why you may not want to attach those security groups, maybe you want that instance to be created, but you don't want to have any network traffic going to it. You don't want it communicating to other devices or instances within your network. You wouldn't put any security groups on them. So that's one reason why we have it. Let's see. The termination. So what this will do, whenever you launch an instance, if you set this to true, the EBS volumes will also be deleted when you terminate them, when you terminate the instance. Or you could set it, I think I reversed that. Delete on termination. Yeah, so if it's true, we delete the EBS volumes when you terminate the instance. If you set it to false, when you terminate the instance, those EBS volumes will persist, just in case you do need them. Moving down, this is just the drop-down of all of our static servers, which ones we want to restore. From there, the snapshot date, at what date and time do we want to restore from. And then down below, termination protection. I recommend this if you have static servers, things that are going to be persistent all year long or however long your life cycles are. This prevents anybody from erroneously manually terminating or from your scripting calls to terminate the process. Scripting is great, but sometimes it can really bite you. That may be one of the things, if you do any termination through scripting and API calls, that's probably something you want to have enabled. So that's really the Rundeck UI per se. Now, once we created that job and we restored this process, we want to know, well, what's a reasonable expectation that a server would come back up? Could it be 15 minutes? Well, that kind of sounds okay. 10 minutes sounded even better. What about 5 minutes? Getting a server from the ground up in 5 minutes and completely be back online, that would have been great. We were not expecting that. So a 1 and 35-second restore time for a production FTP site. That really astonished us. And here's the proof of that. So from the very first time we run the script, we create the volumes. In the very last portion, we restart the instance. So as soon as that instance comes back up, it's live. So that 1 35 isn't from ground up, and it can be hit with traffic. That's just all the different layers that script is going through. So whatever it takes Amazon to restart that instance and come back to a running status, that's the true length of time that we would be down. But for this script to run, it was 1 and 35 seconds. So I apologize. I wasn't sure how big the screens were. It may be better for you guys in the back to look at that. But here is really what we're doing in this script. The first portion, as soon as we run it, we create the volumes. That's great. The second portion is, are we going to attach the security groups or not? On this script, I didn't. So what this says, you can't read it. It tells me the security group IDs was not added. Please make sure you add these manually whenever you are ready. The next portion is polling that instance, since the instance is now running. If anybody has done any API calls, you really have to start polling your instance to get the correct status, because you can't perform specific actions on that instance until it's in a specific state. So as you can see here, it's starting, and the status is pending, pending, pending. The script waits 10 seconds for every single time. Every single pull, it waits 10 seconds. As soon as it becomes in a running state, that tells me and tells the script, okay, I can now start doing whatever I need to that instance. So let's go ahead and add our tags. These are the same tags as we saw a few slides ago, server type, retention days, that sort of thing. So let's add those. Termination protection, we'll go ahead and enable that because that's what we decided we wanted to have. And now we need to stop the instance because we need to detach the root volume. You cannot detach a root volume when a system is running, so you need to stop it. Again, you need to pull that instance until it's in a stopped state. Here you can see it's running, stopping, stopping. As soon as it gets to stopped, then we can perform more actions. Now that it's stopped, we can detach the root volume. And again, the root volume has a status as well. So it's in use. We pull it 10 seconds again until it's available. It's in an available status. Once it's available, it's completely removed from the instance. Let's go ahead and attach the 3 volumes. And again, looking back at that snapshot tag system that we have in place, we know exactly where to put each one of those. So we're not putting a data volume on a system volume and whatnot. And then the very end, it's deleting the original volume so I can save my boss some money on our budget. That way it's not just hanging around costing us money, and restarting the instance. So that's really what our script does. And again, it took about 1 minute and 35 seconds. So managers and directors, this is really geared towards you, but again, it's geared towards anybody. This is a weekly report. We have a Python script, again, running in Rundeck that shows us all of our backup schedules, daily, weekly, monthly, hourly, whatever, all of our instances. Up here, we have volume type and size, the expiration. Expiration is really pulled from retention days on that tag. Oldest snapshot, how many days do we go back? Last snapshot date, and then the snapshot count. Why this is really helpful? Came in very handy for us. A quick story. We were doing some IAM role and user permission updates using kind of like a least permissions idea. And we inadvertently removed a role and privilege from the Rundeck user. So when Aaron got this report, there were snapshots not showing up in here. And we kind of looked back why. And Rundeck has some nice logging where you can see failed jobs. And we looked back and said, well, we didn't have permissions. So we were talking to some of the guys on the group, said, oh yeah, we were doing some permission changes, and we probably inadvertently deleted it. So that's why this is very helpful. Again, something that we have emailed to us every single week. It just helps us keep a keen eye on what actually is going on. So where we are now, again, this is the very same checklist as we went through before. So all of our static servers are now on an automated schedule through the use of tagging. Rapid restore to normal operation, again, I think that spoke for itself. It really impressed us that we were able to do all of that in 1 minute and 35 seconds while maintaining a lot of different options, whether we want to put in security groups, take them out, termination protection, and all of that stuff. A manual and scripted restore option, again, I focused on the scripted option, but the manual restore option really mirrors what we did in code. However, it's in a nice wiki document, step-by-step, with screenshots. So if I'm the one writing this code, I know exactly how it works. But if I leave the company, or I'm sick, or something happens to where I'm not called on to restore this instance, and maybe that script doesn't work anymore. Maybe they changed the Bodo API, or Python 2, version 2, or version 3 no longer works. Who knows? We have a manual process, step-by-step, that has been vetted by somebody else in our organization, somebody other than myself if I wrote it, that can go through it and say, yep, that makes perfect sense on exactly those steps that I need. Adding and removing servers over time. Again, all we have to do is add those 3 tags to our instances, and that Python script does not need to be touched. It can run hourly, daily, whatever. It does not need to be touched. All you're doing, anybody can do this in the EC2 UI, is just updating those tags. You don't have to know code, anything like that. And again, the monitoring and oversight, that table that I just showed really helped us, and it could possibly help you too if you're not doing that currently. And maybe I should just skip the rest since everybody's already doing those automated backups. But just figuring out how to leverage what I'm talking about. If any of this made sense to you, maybe you could pick and choose some of the things that I was talking about. But really determine what your backup your backup process looks like. For us, we're using the live snapshots. What that means is the instance is running, we're taking snapshots of a running instance. There are some potential downsides to that. There may be files in flight that when that snapshot is taken, you may not get that file. Or if you're running Linux and you're running different daemons on there, one of our instances when we restored, we could not restore until we restart the service manually. So the instance got brought up, but no traffic was going to it. We had to SSH into that machine, restart the service manually, and then it came back up. That's not to say that's the case every time. FTP was perfectly fine. The other restorability testing that we done was perfectly fine. This was just on one of our LDAP machines. And again, just something good when you're doing your restorability testing to look for. Stopping the instance and then snapshotting, of course, this is the best practice from Amazon. So if you are able to stop the instance, take the snapshot, that is your best bet. It quiesces the file system, so it's completely stopped. You're not worrying about those files in flight. Again, FTP we can't take down, VPN we can't take down. Those need to be 24/7 machines, which is why we went to our live snapshot model. And no snapshots. Maybe you don't need snapshots. Maybe you're just using the native backups that the application houses. LDAP certainly has one. You can just take the native database backups and use that application to do all that, and you don't need any snapshots whatsoever. But just some things to think of as you're going through this process yourselves. And again, determining which servers you're really going to be backing up. We broke them out to say, we have the scale-out servers versus our static servers. We're only going to be backing up our static servers because our scale-out servers only house our code. And then documenting the process. We use something called Confluence to document our process. It's just an entire wiki. I see nodding heads. How many use Confluence in here? Nice. So you know what I'm talking about. Wonderful. So yeah, it's just a really nice wiki. So all of this is documented in there in a format that our group agreed upon, step by step, with the screenshots to the right of them. And just some other benefits. So whenever we're creating our snapshots and/or AMIs, copying those across regions and across accounts, we operate 2 different accounts, production and development account. So our AMIs may need to go over to the dev side. Our snapshots may go over to the dev side. But we also operate in regions too. So as a part of our backup strategy, we also have a script running that copies from one region to another. So if we have snapshots in our, let's say, west region, if they do not exist over in east, copy them over. So that runs alongside the EBS snapshot script. Incremental backups, again, with the snapshotting that Amazon does, the very first snapshot takes the longest just because you're backing up everything. Those subsequent backups are very, very shorter just because it's only grabbing the blocks that have changed since your last snapshot. That way, for our example on FTP, we have, 2+ terabytes of data. It's not 2+ terabytes every single time we're backing up. That's good because it takes less time and it saves you less money on S3 because you don't have 4+ terabytes, you have a little over 2+ terabytes. That's really all I have, guys. How much time do we have left? Wow, nice. So I can open it up here for questions. Yes, sir?
Why did you use, what was the tool you were using here, job running?
Rundeck.
Why did you use the logging? It looked like you had a custom log rather than CloudTrail. Did you look into CloudTrail at all?
We did. We have many other uses for Rundeck that, whether it's fetching things from GitHub, throwing them into Rundeck. We just have a lot of other uses in, using Python. Rundeck can do Python, Bash, PowerShell, whatever. But since we were comfortable using that, that's really why we decided to go with Rundeck. It was just very, very functional. And with Rundeck, you can send emails on success, on start, and on failure. So again, another nice option that we had there. Good question. Yes, sir? Sure. To now, that's a good question. I looked into that as well. I know there is scripting you can do for Linux machines. So you can quiesce the file system, take the snapshot, and let that file system unfreeze. So you can certainly do that. It's very vague on if you can do that with Windows. I was seeing some things where you could, but now you can't. I was reading some of the community posts on AWS, and some of the representatives from AWS said, yeah, we're aware of that, and we're certainly looking into doing something to allowing you to do that to make a more reliable live snapshot process. But again, that's exactly one of the reasons that you have to take into consider when you do those live snapshots. Of course, yeah.
I think that that's another reason why this scheme works out really well. We've basically decided to mitigate that by saying we're going to be really aggressive with the frequency of our backups. So, we don't necessarily need to get a backup every day or a week for a particular server, but recognizing exactly what you're talking about, we're aggressive with the backups in terms of the frequency, and then number two, we have kind of a manual approach to periodically testing our restorability.
Does your backup restore script detect if the backup failed or not? If you do automatic restore, does it go, hey, it didn't come up and notify you?
On the restore script?
Yes.
Yeah, I mean, we would see that in the output of the restore script itself. In that case, to Jeff's point, we would probably try to do the restore manually, see if that was any more successful. And then if that didn't work, then we'd have to go back to another backup.
Yep. Yes, sir.
So what do you do about consistency groups?
I'm sorry, I couldn't hear you.
What do you do about the consistency groups?
I don't know if I follow. What do you mean by consistency groups?
You've got an application like some complex databases, they'll be configured to write across multiple EPS volumes. What are you doing to ensure they're each of the snapshots that you're taking against the system are consistent with each other, so when you restore, you have a good restore.
Yeah,
Consistent across
Yep.
the servers, the types of servers that we're managing with this particular backup process doesn't play in there. So, we use Dynamo for NoSQL, we use RDS for relational database, and outside of those, obviously, we're using the backup capability that's there. But for the servers we're doing through this process, we don't have that.
You asked one already. Yes, sir.
I just had a question. So you've got some EC2 instances that you're running as long-term static servers.
Yep.
How are you addressing like single file restore? The admin blew up an account file.
Sure.
It's from a week ago or yesterday. How are you doing that with what structure?
So for that process, we wouldn't necessarily run that full restore script. One of the inputs that we have now within Rundeck, we don't necessarily create that instance. We may create the volumes though, and then we may assign those volumes to another instance and go in and see if those files are present, and we can manually copy them. So the restore script doesn't address that specific need. The restore script really addresses if it crashes, if there's massive data loss, to bring that up as fast as possible. But a very good question. You were first, I'll come right back to you.
Roughly speaking, do you have any ratio size between production data and how much you've had to? I've never done a snapshot-based approach for it's always been an application scenario. Each app has its own and at least minimal backup. So do you have any like 1 gigabyte of production data equals roughly 10 gigabytes of S3 storage? I should have.
That I don't. I don't. That's certainly an AWS type question, because when you're taking these snapshots, even though they're stored in the S3, you don't have access to that S3 bucket. They're just in the S3. So when you're taking a snapshot, you're not telling it which bucket to be put into. That's just where they live.
The question is, do you know how much sizing you had to set aside on S3 to support this process?
Yeah,
Yeah.
It's just taking a delta, so it'll depend on how much data you've written between snapshots.
Correct. Yeah, so that's what I was getting back to. Whenever you do the first, so if we do a terabyte, that first snapshot will be a terabyte, but that second snapshot will just be the incremental.
So the change factors a lot.
Correct. Correct. Yeah. Yes, sir.
So based on your answer to this question, it's safe to assume you guys aren't using LVM type objects, or what Linux distribution are you using?
So the different types of Linux, we're using a couple. So Ubuntu for certain machines, CentOS for our LDAP, and Amazon Linux for NAT, things like that.
But you're not using LVM in any of those, right?
I'm not sure. I'm not sure what we're really using.
Yeah.
Well, the reason I'm asking is issues we run into, we're primarily running out of Gentile. There's issues we use LVM across the enterprise, both within our AWS cloud solution and our other virtualization solution. What we run into when trying to do file level restores with a disk with CentOS and Red Hat 6. There's some bugs in the re-import modules that
Gotcha.
don't allow you to resolve the collisions. I'm wondering if you encountered that in your solution.
We have not. The only thing that we encountered when we did a restore, LDAP, one of our LDAP machines uses CentOS, I want to say 5, version 5. Yeah. So that could be one of the reasons why we had the issue. Is when we did that restorability, the service was started, but nothing could hit it. So we had to manually go in. There, through some work that one of our guys did, there was a system file that got hung in a status that could just not be, it was started, but it wasn't really serving any data. So a manual restart of that kicked it right into gear and it was working again. Yes, sir. So Rundeck actually runs on its own instance. So it's a package that you can download. We run it on Linux. I don't know, probably Ubuntu or CentOS, maybe Amazon, the Amazon Linux. But it's a Linux distribution that you can download and install. If you're looking into Rundeck, you have the Rundeck master, and then you can have multiple runners that actually run your job. So if you want to parse out your Python scripts to go to one runner, your PowerShell that goes to another runner to kind of have that separation in case some of your PowerShell fails or kills the system, your PowerShell scripts will still run as well. Yeah, correct. Yeah, whatever their native storage is, we use it there. We don't have it. No, it's not. We did some testing in performance measures to see the kind of spikes when a bigger job runs. We sized the instances appropriately and no log time. But that's a really good question. That's really one of the reasons why to use a runner, because that master houses all of your jobs, and when you run it, it kicks that job off to a completely separate instance. So if you're only running one job at a time, that may not put a lot of weight on your master. But when you click that job, we have it set up so if it's Bash or Python, it goes to a Linux runner, and it runs on that separate instance. So in essence, for Rundeck, we have 3 instances running: one master, one Windows runner, and one Linux runner. So that kind of mitigates that as well. Yes, sir.
Do you have it set up where it'll look at each instance state, and if it fails, it'll do an automatic restore? Is there always somebody that'll do it and just press the button?
So with the common application, we are not short on alarming. I mean, PagerDuty, CloudWatch, different orchestration tools that we use. We get alerts for all of that. And it was funny, one of the things I was talking to Aaron and my guys about is what's the over-under on PagerDuty going off during one of our sessions. So, but yeah, we have many levels of notifications to let us know when whether it's high latency, high CPU. We're alerted to that. It'll pop on one of our screens right behind us. We can kind of investigate and kind of go from there and look at the logs on there and kind of determine what we need to do. Way in the back.
So I have 2 questions.
Sure.
First one, how many backups do you take how far back? Just curiosity. For your FTP.
So for FTP, we are on a 30-day backup. So that retention days tag. So 30 days, we always have the most current 30 days. And as soon as we get that deletion date, the retain until date, once that crosses the current date, we remove it. And the second question?
How did you get around the issue if you take a snapshot of volume that has the operating system on, for example, like CentOS?
Yep.
Sometimes you can't restore it and then you start an instance off of it. Like if you use an instance from the marketplace.
Sure.
So did you get around that?
That's interesting. One of the things I ran into was, if I can try and remember this, I received errors. What's that? Correct, and it comes into like a deleted status or something like that. Yeah, I ran into that. I couldn't hear you. That's one way to do it, yeah. But I found that out when we tried to restore an instance with I believe, a different VM manager. So if I really forget, but I know exactly what you're talking about. I can't remember the specifics, but it doesn't happen to us. We don't have to restore very often or at all. But that's one of the things as I was doing my testing with writing these scripts is, just to play around. And that was one of the things that I saw. And I vaguely remember it dealing with using different, I want to say different distributions or different virtual machine types, something around there. You're welcome. All set? Again, if you didn't want to ask questions during this, we'll stay up here and wait for you guys if you have very specific questions. Thank you for attending.